Alright, for bell work, what we're going to do here is you're going to read the problem and you're going to work on it for a few minutes and then we'll go over it together here. So Bob is sailing on Lake Erie. He sails 2 kilometers north, turns 30 degrees north of east. Now that right there represents the biggest problem you're going to have in the whole problem. 4 kilometers, then he sails due east 6 kilometers. What is his displacement? First thing you need to do is you need to construct a drawing. Why don't you take, 30-40 seconds and do so. I'll pause it here, and so I'll give you a chance to hit the pause button on the playback, and then you can play it. Alright, now hopefully at this point you've got your drawings. Let me move my little arrows I prepared. So the first line, that's no big deal. 2 kilometers north. And then the third one, no big deal, 6 kilometers east. The tricky part is getting the angled vector straightened out. Now, the question really is, where does the angle go? Where does that angle go? Well, first of all, let's throw a couple numbers down here. 2 kilometers, 6 kilometers, 4 kilometers. I'll put it right on the line for right now. The tricky thing is this 30 degrees. Where does that 30 degrees go? And in discussing this north of east idea, we have two options. We could go off here at 30 degrees. We'll call that option A. Or you could go off this way, and you could call that option B. So the question really is 30 degrees north of east, and if you change the directions to forward and right, because east is off to the right of forward, if you were trying to move one direction from forward, would you go 30 degrees? Would this represent 30 degrees forward of right, or would this represent 30 degrees forward of right? The answer is this one, B. It's 30 degrees north of east. So when I'm trying to establish these lines, I want to get some imaginary lines thrown up on the board here. When I say imaginary lines, I'm thinking if you're in a boat, clearly you're not going to see a magical line in the water. But you can look east and have a line that goes off to the east that you can base off of. Compasses help you here. So if that's my line off to the east, and then if I have another one that goes off to the north, now check out what this enables us to do. We went 30 degrees to the north side of east. That's north of east. If we went the other way, it'd be south of east, right? Whenever you encounter these kind of sayings, the second word is what you base yourself off of. The first word is what you modify with. So east is my base, go north of it. Okay, so there's my angle. Given that information, I think you guys are capable of finding these two purple lines using SOHCAHTOA. So why don't you pause the recording for a minute and calculate what your two letters are going to be. Let's call this one X and let's call this one Y. So pause the recording for a few minutes while you guys calculate this. Have you got it? Alright, I calculated it here. I found my distance to be 3.5 kilometers here, and then this one over here to be 2 kilometers. Now, how did I get those, if you're asking? Is I did on this side, because this X is the adjacent side of the triangle, so I'm going to use cosine for that. I'm going to say 4 kilometers times the cosine of 30 degrees. Now if you get some goofy answer, your calculator might be in radians. Be careful of that, it'll get you every time. Then I took sine to get over here. I said 4 kilometers times the sine of 30, and that gave me 2 kilometers. And you might be thinking in your head, why does this matter? And it matters because those distances will allow us to finish it off. So really, that 2 kilometers is the same as this 2 kilometers, and that 3.5 kilometers is the same as that 3.5 kilometers. Remember, we can move vectors around as necessary. So 3.5, I can put it here. 2, I can put it here. Given that, 3.5, 2, all of a sudden, now it has 30 technically goes there at this point. Now all of a sudden, it starts to look like a great big triangle, even if we get rid of this one. By breaking it apart into two pieces, we can get rid of that one so you can see it. I very much recommend constantly redrawing your triangles as you go. Now I think it's something we can very much solve for right here. Did I move the numbers wrong? I totally moved the numbers wrong. I apologize for you. The 2 goes over here, the 3.5 goes there. If you're confused, that's my fault on that one. So, that's gone. Now we can see Bob went north 2, and from over here went north 2. Then Bob went 3.5 east, and then 6 east. For a total of 4 kilometers north and 9.5 kilometers to the east. 4 and 9.5. Now I'm just going to move these guys out of the way. That's 4, and then these guys, I'm going to move them out of the way. 9.5. At this point, you can use Pythagorean theorem, and you can calculate how far that is. I'll give you a couple seconds to do that one here. I'm not even going to pause it. I'm just going to let the video run while you calculate it, because I'm going to calculate it too. There's the bird, by the way, in case you're missing it today. So using Pythagorean theorem, 4 squared plus 9.5 squared equals c squared, and then you square root it. I got 106.25, and then I square rooted that, and that came down to a whopping big 10.3 kilometers. Now, that's the resolution of this problem, but understand that this problem has the potential to be very frustrating because it's the first time we've done something like this. It's not easy. It'll get easier because we're going to practice it. So if this is very stressful to you, don't worry, we'll do everything we can to decrease that stress as we go over more and more examples. Alright? Good luck.